This is station number 1. What I have up here is a pop can. It has a little bit of water in it that is boiling, so I'm making hot water vapor, okay? So that's where my kind of initial conditions are. I have hot water vapor. What I'm gonna do is I'm gonna take the can and put it inside this water bath, basically sealing off the can. Ready? So that's what happened to the can when I put that hot gas into the cold. Based on heat transfer, that gas got cold. Okay, so that's what happened to the can when we cooled off the gas. Station 1. So this is experiment number 2. There's water in the pan and this candle is lit. I invert it and the candle goes out. So think about what I changed going from the candle being lit to not being lit, and then notice that the volume of the liquid, well, what the volume inside the can was, now there's more water inside than there was before. And that is experiment number 2. This is the third experiment called the Cartesian diver. Inside this bottle, there's a little dropper. It's kind of hard to see, it's over on the side. And when I squeeze my bottle, that dropper drops to the bottom. When I let go, it comes back up. So if you look really closely at it, that dropper has water inside it. And when I squeeze, that water goes up. Okay, so what I'm doing is squeezing. I'm kind of pushing really hard. And what that does is changes the amount of gas. So the liquid is changing, but it's also because of the gas changing. So think about the gas inside the dropper and what's causing this to drop based on the fact that I'm squeezing the bottle. This is station 4, and what I have here is a little pressure sensor that's recording how much pressure is inside this bulb down here, depending on what's going on with the gas inside the bulb. Okay, so right now it's in hotter water. So you can see what's happening to the pressure sensor in hot water. And then if I move it over to cold water, the pressure should change. So the cold water is cooling the gas inside, and so the pressure is changing to, based on that change to the gases. So you can see what's happening to that pressure dial as I cool my gases. And again, I'll show you again, we'll go back to the warm. So as I warm up my gases, what happens to the pressure dial? Hopefully it's happening. And then as I cool down my gases, what's happening to the pressure dial? Oh, I think it's moving. Okay, so that's station 4. How is the pressure dial being affected by the temperature of the gas? This is station number 5 with a marshmallow inside the syringe. I'm gonna put my finger on the end, and then I'm gonna move the plunger so you can see what's happening to the marshmallow as I pull the plunger out. And then you can see what's happening to the marshmallow as I push the plunger in. Okay, so the marshmallow essentially is filled with gas. So the marshmallow shows us what's happening to the gas as I push the plunger in and pull the plunger out. Okay, so that's station 5. This is station 6, where I'm taking the syringe attached to a pressure sensor. And as I compress the syringe to different volumes, the pressure will show up on this device. So that is the pressure for 8 mils of gas. That is the pressure for 6 mils of gas. So just kind of decide, it might be fluctuating a little bit, but that's fine. Just write down kind of the number that it's at most often. That is the pressure for 10 mils. That is the pressure for 12 mils. That's the pressure for 14 mils. That's the pressure for 16 mils. That's the pressure for 18 mils. So record those numbers in the data table for what the pressure is per volume.